Okay, so we're going to continue in our discussion of frequency tables. The only difference is in the previous example to this example, instead of listing out our data values individually, right, we had a lot of rows in that last frequency table that we looked at. It could be easier for us and it could be beneficial to us to organize our data values into groups instead of single individual data values as we're looking at the frequency. So when we're putting our data in groups, we call those groups either classes or bins. So in this particular example, we're going to look at a frequency table that organizes our data by grouping values in these classes or bins. Right, underneath here, we do have our instructions again for StatCrunch. Again, take a look online. You should see a separate link that kind of works you through this process step by step, showing you what kind of information you get from there. We're going to choose to work through this example down at the bottom by hand, just as we did the one on the previous example. All right, so what we have here is we have the same data set that we saw in our previous example, but we are listed different values for our bins. So we have 9 to 12, 12 to 15, so on and so forth. Notice that the number at the end and beginning is the same. Because if we're thinking about this, eventually we're going to graph this. We want to be able to label different things in our pictures using these numbers. But the only problem is we can't count 12 in both places. Right? We have one person that scored 12 goals. Well, we can't count them in both our first row and our second row. We can only count them in one of those places. So what we're going to do is we're going to include it in the bin or class that starts with that number. So instead of being 9 to 12, we're really thinking 9 to 11. Instead of being 12 to 15, we're really thinking 12 to 14. Right? The 15 is going to get included in this next one, which will then go to 17, so on and so forth. Right, so we have 20, 23, and 35. One way we can show this mathematically is by using interval notation. When we're using interval notation shows us a range of values, and whether or not our numbers on the ends are included is shown by different symbols. So this first bin or class from 9 to 12, I'm going to write 9 with a square bracket, and then I'm going to write 12 with a parenthesis. The square bracket means that the 9 is included. The parenthesis means that the 12 is not included. The 12 is going to be included in our next bin. So this is going to be 12 to 15. The 12 gets the square bracket, the 15 gets the parenthesis. Then we're going to have 15 to 18. Square bracket to include the 15, parentheses so we don't include the 18. Right, 18 square bracket to 21 parenthesis, 21 square bracket to 24 parenthesis, 33 square bracket to 36 parenthesis. Right, I bring up interval notation because it is something that we do see in other math classes. It is something that's kind of commonly shown if we're dealing with these bins and things. I know, for instance, it does show up in one of the mini quizzes for this section, so I just kind of want to bring that up, and we'll go through it in a couple of different examples here. Right, so square bracket means it's included, the parenthesis means it's not included. Right, so our frequency, we want to count the number of values that occur for each of these bins or classes. Right, so 9 to 12, which is really our 9 to 11, 1, 2, 3, 4, 5. 12 to 15, which is really just 12 through 14, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, 15 to 17, we have 1, 2, 3, 4, 5, 6. Right, 18 to 21, is really 18 to 20, 1, 2, 3, 4, 5, 6. 21 to 24, there's 1. 33 to 35, there's 1. All right, our relative frequency is still a proportion. All right, so we're still counting to get our frequency. All right, so we'll go ahead and label counting to get our frequency, and we're finding a proportion for our relative frequency. Right, the only thing that's different is we're not looking at individual data values, we're looking at groups. But we still find our relative frequency the same way. We're going to go ahead and divide. 5 divided by 28 gives us 0.179. 9 divided by 28 gives us 0.321. 6 divided by 28 gives us 0.214. 6 divided by 28 gives us, again, 0.214. 1 divided by 28 gives us 0.036. And then this last one, again, we're taking 1 divided by 28, which still gives us 0.036. Right. Now, one thing to mention as we're adding these up, we do get 28 for our total. Right? So, which I totaled on the last one. In this case, we should know, but it's always a good way to double check. Right? Make sure that your total here adds up to the total number of values that we have in here. And then also one other thing to kind of point out, relative frequency, if we add these up, these should add up to roughly 1. It could be a tiny bit, something like 1.001 or something along those lines, because we are rounding. But as we add these up, these should add up to 1 or 100%, right? Because we can also think about these as percentages, 17.9%, 32%, and so on and so forth. So if we add those all up, we do get 100%. Right? So a good way to kind of double check your frequency tables, relative frequencies, if you want to, make sure that all the totals match up, right? Make sure that everything matches up with your original data set.